Hello, welcome to the showcase of Group 18, Augmented Reality and Drones. Okay, normally we call augmented reality as AR. So, what is AR? AR is a kind of technology that expands the physical world and adds layers of digital information, such as sounds, videos, and graphics, onto the real world. It is always compared with VR, and the performance of AR technology can be more intuitive and much easier to understand under the comparison. So, unlike VR, AR doesn't create the whole artificial environment. The main objective of it is to enhance the existing environment by overlaying new information on top of it. And there are three features of AR technology. First, it has to combine the real world and the virtual elements. The second one is called register in 3D. This refers to that AR applications are written in special 3D programs, which allow developers to tie animation or contextual digital information in the computer program to an AR marker in the real world. When an AR application receives digital information from a known marker, it begins to execute the marker's code and layer the correct images. And of course, interactive in real time is also an important characteristic of AR technology. Our next topic is how does AR work? As you see, AR technology can work using the four approaches. First is called marker-based. Such kind of AR uses a camera to identify visual markers or objects, such as a QR code or natural feature tracking markers, and show an overlay only when the marker is sensed by the device. It depends on device camera to distinguish a marker from other real-world objects. The second approach is called location-based. It relies on a GPS, digital compass, velocity meter, or accelerometer to provide data about the location, and augmented reality visualizations are activated based on these inputs. Actually, it is also known as markerless AR. This kind of technology is often used for mapping directions, finding nearby services, and other location-based services. Another kind of AR technology is projection-based. It uses projection technology to enhance objects in the real world by projecting images onto their visible surfaces. Here is an example. You can see from this video that light is projected on the building to achieve projection-based AR. And the final one is called superimposition-based. It replaces the original view with an augmented, either fully or partially. One good example is IKEA catalog app, which allows users to replace virtual items in the furniture catalog in their real rooms. Now let's turn to drones. A drone is another name of an unmanned aerial vehicle, an aircraft that is operated without a human pilot on board. Drone technology can be an effective tool for surveillance, providing real-time data. Drones are previously used for law enforcement and the military, but now also for entertainment as well. Look at the model on this photo. It has been a popular recreational product, and you can always find it in shopping malls and e-commerce sites. Drones have become a big business over the last few years, and the market is continuing to grow. As we said above, drones can be used for surveillance and providing real-time data. How? By sensors, including position and movement sensors for information about aircraft state, exteroceptive sensors dealing with external information like distance measurements, and finally, the camera. And these sensors have created opportunities for applying AR just like how we apply AR on phones with sensors. For applications based on drones and AR, computing tasks are divided to two parts. One is the part processed by the ground processor in phones or tablets. The other is processed by drones onboard processor. A ground processor handles real-time localization, forwarding of commands, generation and delivery of augmented content to users, along with safety features and overrides. The UV's onboard processors and autopilot execute the commands and provide a redundant source of safety features and override in the case of loss of signal. When the drone is connected to a mobile device, the real-world images come from the camera attached to the drone, and the virtual world is superimposed on that image and appears on the drone's pilot's smartphone or tablet, appearing as the images with information like marks and text on them or even overlapping them with virtual objects. You will hear details about how drones and AR work together based on specific application cases later by our group members. Well, companies have enabled various complex AR projects through mobile devices in many areas, including maps, real estate, emergency services, medicine, and games.
Now, to inspect the current developments of drone-related AR applications, we will take an AR game for drones as an example. Drone Pre-AR is the first AR game for drones, developed by game company Edgebees in cooperation with DJI, a world-leading drone company. It combines first-person view drone piloting with a racing game. Pilots need to navigate the course while collecting checkpoints and prizes, avoiding obstacles, and complete it before the clock runs out. The game features dozens of virtual obstacle courses at increasing levels of difficulty. Players will be rewarded for both speed and accuracy based on their performance. A leaderboard will inspire people to reach higher levels and compete with one another. It also allows drone pilots to share their achievements on social media. And according to Edgebee's official website, in the near future, players will be able to fly and compete simultaneously using a multiplayer format. In order to provide a user experience, we tested the application with the DJI Mavic Pro and included remote controller. An iPhone X was connected to the remote controller to display the camera view and run the game. We chose to launch the drone from the area between the Melbourne Exhibition Garden and the Melbourne Museum. Through the test, we found the application to be compatible and stable with the drone and remote controller. The location of AR objects can respond quickly based on the drone movement and attitude. In general, the game has high playability and inspires players to improve their scores. As players strive to climb the leaderboard, their piloting abilities will, in turn, improve. In spite of these advantages, the application has some points that need improvement. The layout of track is too limited to fly along. With such a small route, inertia will often throw players off track and make it difficult to get back. Also, the drone's inbuilt obstacle avoidance function is not available in the application. Players have to check the environment by themselves. Next, let's look into the mechanism of this AR game working with a drone. While playing Drone Pre-AR, there are three main devices that collaborate with each other: a drone, a remote controller, and a smartphone that works to display and run the application. The controller will exchange information with the drone via radio, control the drone's movement, and receive data from the drone. This data will simultaneously pass to the smartphone via USB connection and be processed by the application in order to render the virtual objects and present the video together in real time. The data is collected through the various sensors on the drone. These include a camera to provide front vision, a GPS to provide location, a compass, a gyroscope, and an accelerometer to measure the drone's position and movement, and a 3-axis gimbal to measure the camera angle. As for the AR technology, the Edgebee official website states that Drone Pre-AR uses superimposed AR, the same style as used in Pokemon Go. While some superimposed AR programs also use real-time image recognition, it seems to us that the one using Drone Pre-AR renders the virtual objects all from the sensor's data such as direction, movement, and attitude. It only takes the real-world image as a background, just like Pokemon Go. We ran another experiment and tested the application again with the camera covered while flying the drone. The virtual objects still responded to the drone movement as before. It was as if we were playing the game without the real-world background. This confirmed our speculation. This is our overview of one example of AR application in drone technology. But before we finish this video, it is worth mentioning that Edgebee has developed another application called First Response Pilot, which includes features such as overlaying maps over the real-world image, placing various types of markers over the image on the map, and sharing markers and drone location with other people in the same mission. Applications like this can make a difference in the case of an emergency. We are looking forward to more implementations of AR and drone technology in our world.